The asteroid belt is an area located between Mars and Jupiter that contains millions of rocks, dust, and other particles. It is the most noticeable feature of the solar system, since it marks the limit of the inner solar system. It has been estimated that the total mass of objects in the asteroid belt is only a fraction of the mass of the Moon. Most of the asteroids in the belt are irregularly shaped and vary in size from a few tens of meters to several hundred kilometers. The largest asteroid is called Ceres and is even classified as a dwarf planet. In the short term, the accompanying megatsunamis caused by the impact would be capable of leveling coastlines everywhere. In the long term, the loss of sunlight would make crop production impossible and the decline in the atmosphere could cause mass migrations. Understanding the behavior of asteroids is critical if we are to make efforts to protect ourselves from a potential asteroid strike. We need to develop a better understanding of an asteroid's movements and trajectories, and increase our ability to detect supersized objects when they approach the planet. With current technology, detecting an asteroid far enough away to provide adequate time to prepare a defense system is extremely difficult. However, scientists have been researching methods to deflect the asteroid or break it apart by force, as well as methods to conduct a controlled landing on the asteroid. Some of the proposed solutions utilize the solar system's existing resources, such as redirecting gravity or using gravity tractor forces to tug the asteroid in a different direction. Other proposed methods rely on devices to generate thrust, such as heavy explosives, lasers, or even nuclear bombs. In the event of an imminent impact, the most immediate solution might be to send a large spacecraft at the asteroid to break it apart. Although any of these solutions appears to be plausible, the success of one or more of them still needs to be tested in a controlled environment. There have been some advances in technology that allow for easier detection of asteroids than ever before. For instance, the NASA-funded Near-Earth Object Wide Field Survey Explorer, NEOWISE, program has been scanning near-Earth space and provides a much-needed layer of protection. With advanced technology, it may become possible to detect hazardous near-Earth objects that may be carrying deadly cargo, such as an asteroid. However, despite the advances in asteroid detection technology, it is still difficult to predict exactly when and where an asteroid may impact Earth. As such, scientists are working diligently to develop a plan for Earth in the case of an asteroid strike. There are several strategies for A. Evacuating populations from potential impact areas, B. Developing shelters and systems of shelters to protect those who don't have adequate warning of an impending impact, and C. Assigning resources and support teams to handle the aftermath of such an event. In addition to these measures, the development and implementation of an emergency response program is being explored. This program would help coordinate local, state, federal, and international actions that could be taken in the case of a potential asteroid strike. However, this is a complex process and one that requires a great deal of cooperation and coordination amongst multiple stakeholders. Unfortunately, the costs of such a program or the resources needed to implement the necessary infrastructure could be quite substantial.